I think as we progress with AI and build up more capabilities, we'll be able to compare these systems with the human mind to see what the differences are.
Have you ever wondered what it would look like if one of the leading teams in artificial intelligence applied their knowledge to the field of robotics? Let's explore this fascinating topic. DeepMind, Google's cutting-edge AI division, renowned for several groundbreaking AI technologies, has unveiled a revolutionary project known as Robocat. Contrary to what one might think, DeepMind's creation is not the robot itself, but the complex AI system that propels it. The actual robotic framework is a Sawyer robot, a high-precision machine commonly utilized in various industrial contexts. Let's delve into why DeepMind's Robocat is truly a game-changer in robotics. One critical challenge facing robotics today, also familiar to large language model researchers, is the hurdle of training data. Traditional approaches to AI necessitate vast volumes of training data for a machine to perform a given task with proficiency. This usually involves observing hundreds of thousands of examples, a time-consuming process that has been a bottleneck for development in this field. DeepMind's Robocat addresses this issue by pioneering a method for self-generating new training data. This dramatically reduces the time it takes for the robot to understand and perfect a task. In numbers provided by DeepMind, Robocat can grasp a new task with as few as 100 demonstrations due to its utilization of a comprehensive and diverse dataset. This marks a major step forward in robotics, significantly accelerating research in the area and decreasing the need for human-supervised training. Before examining the significance of Robocat, it's worth understanding the pedigree of its creators. DeepMind is a tour de force in AI, responsible for innovations that have significantly impacted our world. They developed AlphaFold, an application capable of predicting 3D models of protein structures with remarkable accuracy, a tool that's accelerating research across multiple biology fields. They also crafted AlphaGo, the first AI to defeat a professional human Go player and a Go world champion, cementing its place as arguably the most potent Go player in history. Their creation, WaveNet, is yet another noteworthy accomplishment, generating more natural-sounding speech for a wide array of products used by millions globally. The preceding achievements of DeepMind underline the caliber of the team behind Robocat, making it clear that this isn't an ordinary robotics project. Robocat isn't just another robot, but represents a paradigm shift in AI-powered robotics, continuing the tradition of breakthroughs set by the remarkable team at Google DeepMind. As we fast approach the era of general-purpose robots and artificial general intelligence, AGI, Google's DeepMind has given us a preview of the future with its new project Robocat. But what makes Robocat so distinctive and to some extent rather formidable? What really caught our attention about DeepMind's Robocat is its versatility. The AI-powered robot has been programmed to operate not only with a specific manipulator but essentially any arm that's available. DeepMind released multiple examples of Robocat's proficiency. In one, the robots were given a target image to replicate. They performed this task remarkably well. The demonstration extended to showcase that even when confronted with tasks or robotic systems not previously encountered during training, Robocat managed to accomplish them effectively. This underlines why Robocat is seen as such a groundbreaking project. The paper published by DeepMind also explored how Robocat reacts to environmental disturbances. Although this aspect has been previously highlighted in other papers from Google, being able to quickly and robustly adapt to unforeseen scenarios is key for the effectiveness of these robots in real-world applications. While researching Robocat, an intriguing detail emerged. Google also has its own multimodal model named Gato, which translates to cat in Spanish, also pronounced as gato. This could be seen as a hint at Google's ongoing interest in developing AI models that push the boundaries of what we currently know and can achieve, much like Robocat. DeepMind's Robocat is not just a marvel of modern robotics, it's also an indication of the groundbreaking work Google's AI division is doing with their ongoing project named Gemini. This artificial intelligence program is being meticulously developed to compete with OpenAI's GPT-4 and GPT-5 models. An integral part of Robocat's effectiveness stems from Google's multimodal model, Gato, capable of processing language, images, and actions across both simulated and physical environments. There is a growing consensus among experts that multimodal models like Gato will shape the future of artificial intelligence. The feature that truly sets Robocat apart is its ability to self-improve autonomously. This is achieved by combining Gato's architecture with an extensive dataset consisting of image and action sequences of various robotic arms performing a multitude of tasks. The autonomous generation of additional training data fuels Robocat's learning cycle. Interestingly, the type of training data Robocat uses differs from the traditional approach in robotics. Commonly, 5 types of data are used in robotic training, including sensor data. Sensor data encapsulates information from a variety of sources, such as cameras and depth sensors, which the robotic arm uses to perceive its environment. But with Robocat, we see a fresh and innovative approach that pushes the boundaries of robotics, offering an exciting glimpse into the future of the field. In addition to sensor data, Robocat's training employs a wide variety of data types. This data variety is pivotal in allowing the robotic system to perceive its environment and function efficiently. Demonstrational data, gathered from a human operator performing tasks using the robot arm, is also crucial. Furthermore, reinforcement signals guide the learning process, indicating the success or failure of certain actions or states. Synthetic simulation data, like sensor readings and robot configurations simulated in an environment similar to NVIDIA's Isaac Sim, also contributes to the training process. However, what sets Robocat apart are 2 additional types of training data: video data and self-generated training data, enabled by its multimodal features. These different types of training data have paved the way for Robocat to train itself on robotic arms it has never encountered before and adapt to different controllable inputs. For instance, the core highlight of Robocat, and indeed a significant milestone for DeepMind, is its ability to continually self-improve. This continuous learning loop allows Robocat to get better at learning new tasks as it takes on more of them. In essence, it's a virtuous cycle of training that underscores the revolutionary nature of this AI-powered robotic system. DeepMind's Robocat is undoubtedly a game changer in the world of AI-powered robotics. Its initial success rate was 36% on unseen tasks. However, as it trained on a broader range of tasks, the success rate more than doubled. This paves the way for a new generation of more useful robotic agents. Robocat's capability to generalize new tasks and robots, both unseen and through adaptation with a limited number of examples, is indeed impressive. Furthermore, its adaptability and generalization make it highly versatile and efficient in learning new skills. Notably, Robocat can generate its own training data for subsequent iterations, establishing a unique self-improvement loop. This iterative learning process significantly contributes to its autonomous improvement, enhancing its capabilities over time. The combination of visual goal conditioning, adaptability, generalization, and self-improvement sets Robocat apart from previous AI robotic systems, marking it as a groundbreaking development in the field. DeepMind's Gato, multimodal, multitask, multi-embodiment generic policy, presents significant potential for future applications. So, as we end this deep dive into the innovative world of DeepMind's Robocat, we have a question for you. What potential applications can you imagine for Robocat in your daily life? Do you think the ability of AI to learn and improve autonomously is a game changer or a cause for concern? Please share your thoughts in the comments below.